Okay, so one really good question that a lot of you asked in the 1 minute papers was, why can you choose your pivot in a statics problem? So that's a really good question. And so I'm going to just explain it both conceptually and also prove it mathematically. So I'm going to use this example of a bar that's 2 meters long. There's a 3 Newton force upward at the end of it, a 6 Newton force going down in the middle of it, and then we found in the previous video that must also be a 3 Newton force upward. That's just so in the y direction there's no force and the thing is static. You have 3 plus 3, 6 newtons up, and then 6 newtons down. And so the reason why you can choose your pivot, I chose it over here in the previous video, or you could choose it here or really anywhere, is because your equation for a statics problem that involves torques and rotation is the sum of torques equals to 0. And so what that means is that all of your torques are going to create no rotation. So the 0 is because we know that there's no turning. There's no torques that are going to cause the thing to rotate. So if you have no rotation around this point, then that means this thing just isn't rotating. So it's also not rotating around here, it's not rotating around here, it's not turning at all. So there has to be a sum of torques equal to 0 no matter where you are. So that's conceptually why you can choose your pivot in a statics problem. But mathematically, you also might wonder. So let's use this example to just prove it mathematically. And if you're not interested in that, then you can just go do something else. But for those of you who want to see a proof of this, I'm just going to show you that. So your sum of torques, if you were to choose your pivot here, is going to be 1 meter times this negative 6 newtons. So that's 1 meter times 6 newtons, and this is negative. And then it's plus your lever arm. So your lever arm for the 3 Newton one is going to be plus 2 meters times 3 newtons. And so you can see that this is negative 6 plus 6 Newton meters. So this is equal to 0 Newton meters. And so it's easy to see that our torques sum to 0 when our pivot's here. So let's show that if we moved over a distance L, chose our pivot somewhere else, that we'd also get 0, and we'd have to get 0, and that's how we'll prove it. So I'll do that by saying, okay, now we're at point A. So now we have sum of the torques around this point A is equal to, okay, so now our lever arm has changed not only for these two forces, but also for this third one that was at the pivot that I didn't think about over here because there was a 0 lever arm. The lever arm didn't matter. So here, the lever arm for this 3 Newton force is going to be L, and then we have 3 newtons. And then now the lever arm for the 6 Newton force is going to be, well, so we have negative just from the 6 newtons, but the lever arm is going to be L plus 1 meter, so that's L plus 1 meter times this negative 6 Newton force. And then the lever arm for the 3 Newton force is going to be this 2 meters plus L. So that's plus 2 meters plus L times our 3 Newton force. And so what we can do now is we can write this as a term that has L times a bunch of things. Just break out each of these L terms and separate that out. So it's going to be L times 3 newtons minus this minus 6 newtons, that one. And then this term is going to be plus 3 newtons. And then we'll have just the same thing that we had up here for all the terms that don't have L's in them. That's minus 6 Newton meters plus 2 meters times 3 newtons. And so this right here we know is just the same as this, so that's equal to 0. And since this equation, we can also see that it's L times 3 minus 6 plus 3, so this is also 0. So was this just a coincidence that this happened? Actually, no. You could instead write this term as L times the sum of all the forces in the y direction. And that'll happen anytime you do a problem like this. If you move the pivot by a distance L, then you'll get L times the sum of the forces in the y direction. But we know that this has to be equal to 0. The sum of the forces in the y direction is equal to 0 if the thing isn't moving. And in a statics problem, it's not moving. So that means no matter where your pivot is, as long as your thing isn't moving up or down, then also your torque is going to be 0 around that pivot, any pivot. So I hope I've convinced you, and I hope this is useful. And as always, don't hesitate to ask questions.